Hello everyone, can you hear me? Can you hear me? Hello everyone, can you hear me?
Yes,
Oh, perfect. I think we have an all-lady class at this moment. If I'm right or I'm not, I don't know. I'm not 100% sure about GU, but yeah. Anyways, so only four people are here, and I'll start anyway. All right. So let's begin with what we have talked about last time, and I'm going to open up the poll so we can go through it very quickly and sharing the screen. All right. Also, make sure this is being recorded. Fantastic. All right. So let's begin. We talked about files. We talked about ASCII files and the insertion operator, and we said when insertion operator inserts values into a file, we let me just open that one up so we see. It interprets whatever that you have in those values into text and puts it in file. These are all values that are readable by us, and the outcome of whatever that we have inside these files that are created are essentially exactly what we could print on the screen, but instead we saved in a file. Problem with this is that each record has a different size based on the reinterpretation of the data in the file. Therefore, it is impossible to find out exactly at which sequence what data is and which address. So essentially, if I wanted to find the fifth record, I have to read one, two, three, four records and know that the next one that I'm going to read is going to be fifth. It is impossible to jump to that exact location in the file. Whereas in binary files, the story is completely different. With binary files, let me just open the binary right. When I create a file, I open the file as binary and I'm going to call it bin so we know it's binary. And when I put individual values, write it in a file, I use the write method instead of the insertion operator. So the write method does not do any type of interpretation of the data. All it needs is the address of the beginning of the data as a constant character pointer and the number of bytes it's supposed to write. It goes to that address, writes those many bytes into the file, and it's done. No interpretation is happening in write. Therefore, the outcome of the process of writing these eight numbers is essentially 64 bytes, and each 8 bytes that you see in memory is essentially a representation of uh, the number that you have. So essentially, this is the first number, this is the second number, this is the third number, and it goes right down to 8, total of 64 bytes, and that is our file. We said this gives us an advantage. The reason is that when you have a file that the number of records are identical, if I want the fifth record over here, all I need to do is multiply size of a double to 4, which is 32. Then I'll go 32 bytes further, and I'm going to be standing right before the fifth byte. And then I can actually read that byte and I'm done. So that's how the binary files are used. Now to show that actually how it's done, we said that I'm going to read the file. Now this time instead of writing the file, I'm going to read the file using the read command. Again, read does not do any type of interpretation. What it does, it goes to a certain It starts where the file is supposed to be, where the file pointer is, and reads to the number of bytes that you mention and puts them in the address you have given to it, that it's a character address, character pointer. So byte by byte will be written and it will be put over there. Now, if the values you're reading from the file corresponds with the type of the address the pointer is pointing to, then you have a valid value in memory. Other than that, it's going to be all garbage. Because we just created our file with doubles, therefore that's what happens over here, and every single individual that is read over here goes back to v1 by 1 and is printed, and the outcome for it is exactly what we have printed, what we have saved in a file. Looking at the execution, we see that obviously every single value that is read is exactly what we have put in a file. Let me just make this a bit smaller. So all the values are read perfectly, and when it reaches to the end that it cannot read returns the file itself, and therefore it goes to a failed state. Now I'm clearing the file, and I'm going to say seek G because I am using IF stream. It's seek G. If it was OF stream, it would have been seek P. So any of these functions, seek or tell, if you add a G at the end, it means for reading, stands for get, and P is to write something in a file, and it stands for put. So seek G, it means jump to this address to read, and seek P means jump to this address to write. So it jumps to that address, so jump to the address, it means it goes to address 16 and starts reading from that one, write 8 bytes and puts it in V, and therefore that becomes a third record. Now I can actually go to the end, so seek G with 2 arguments. The first one is the offset that can be either positive or negative, and the second one is the direction. The direction can have 3 different things. It's iOS end, iOS beginning, or iOS current for current location. So for example, if I read something and I want to reread it, I have to seek G to the negative size of the type from current location. Anyways, now that it goes to the end, so this essentially says go to the end of the file. Now if I do a tell G, POS will actually hold the position of the offset of the file, which is 64. Therefore, it is exactly 64 bytes, and I can actually show that out. Then I can do seek G to position, which is the end of the file, minus size of 1 double. Therefore, it's going to stand on the last one, and when I read, that's going to be the last element in the data. Now I can say go to the beginning and 0 bytes over there. It means stand over there, and that's going to be the first one. If you want it to be second one, then it should have been size of double. Now I'm going to say go to the end of the file and come back 8 bytes. So size of V gives you a size of a double, and this gives you stream offset. You do a minus, and that's the negative side. And so it comes right before the last record, and the last record is written, and the file is displayed. The value is displayed. This, ladies and gentlemen, is called random access, where you go up and down through your file based on your need and the addresses that you want to jump into. Are we okay down to this point? All right. So Now that we are okay down to this point, and this I'm gonna call, you know what, let me put this at right over here and expand it. There you go. So I'm gonna call this one C random access binary file.cpp. Obviously, if I ever want to find out what is the size of a file and what are the number of records in a file, the easiest way to do is to go to the end of the file, see where is the position of the end of the file, and then print that value. That's the position of the end of the file, divided by the size of the record you have, which is a double. So it's size of V. I'm going to put over here V, doesn't make any difference. So you say the size of the file, size of the record, and that's going to give you the number of records. And you run that program, you will see that in my numbers.bin I have exactly 8 records and the size of the file is 64. Are we okay with this one? All right, Farida, why not? What's up?
I'm a little confused about the line 9, where it says stream BOSS and
Okay,
then
stream position
file.lg.
is essentially an unsigned integer. Not an unsigned integer, sorry. Yeah, it is unsigned. Stream position is an unsigned integer. So what is the position in the file? So I told to my file to go to 0 bytes after the end. That means the end of the file, right? So this essentially
Yeah.
means go to end of the file. Now in here I'm going to say tell me where you are. Tell me what is your position. So the position that it's going to give you, it's let me, no, tell me. Tell me, okay? Tell me. Okay, so this tell G tells where it's in a file. Therefore, S will be the number of bytes that you have at the end of the file. That's the position. Then showing that shows the size of the file. Now I have the size of the file and I have several records in a file. Obviously, sum of size of all the records is the size of my file. Therefore, if I divide it, I'll get the size of the individual. Does that make sense?
Kind of.
Okay, so let's mention it like this. If this is the size of my file, and it's 16, and this is the size of my record, that is 4. If I put 4 of these over here, it makes 16, correct?
Mm-hmm.
Therefore, if I divide 16 by 4, it's going to tell me how many are there. As easy as that.
Okay, I see.
So you
So
just
is stream pause also like, can you use that as a type?
stream pause. This
Yeah.
one,
Yeah.
that is a type. That is a
Okay, and
type.
then you said it's only for unassigned int, right?
No, no, no. It's not for unsigned int. I said it's like unsigned integer. An unsigned integer is an integer that cannot go negative, right?
Mm-hmm.
Stream position has other properties. It's a type of a class, but it's a type. It's a type created to hold the position of the next read or write in a file. So essentially,
I see.
yeah, so when you put over here something, when you say, if I say file.seekg 10, this 10 is stream position. I'm saying go to byte 10. So seekg with one argument receives stream position. So this 10, so 10 is of type stream position. and stream position cannot be empty. It cannot be negative because you cannot have a file with negative. Whereas in seek G over here, 0 is of type stream offset, which can be positive or negative. It means from this location, if you put positive value, go forward. If you put negative value, it means go backwards. So seek G says from where to go. Got it?
Yes, makes sense. Thank
And
you so
this
much.
end, it can be end, beginning, or current. You can say from the beginning of the file go that much, from current location of file go that much, and so on and so forth. Yeah, anyway, so this program simply shows you what is the size of a file and how many records you have in a file. Okay. One more thing I need to tell you, it's very important, is that seeking does not fail the class. Okay? Oh, I put it in the wrong place. Yeah, seeking does not file the does not fail the object. Look at the code that I have written. I am reading. We know that nums has it is 64 bits, it has 8 records in it, right? So I'm going to say read the first one. That's the first one. Then I'm going to go seek 1,000 doubles, thousand, go to position 8,000. We know the position is 64, but if you check the fail after that, it will not fail because seeks is will not fail the class. To check to see if it's actually failed or not, you have to actually read it. Okay, if you read it, then it will tell you if it's failed or not. So if I run this program, if I run this program, you will see that it reads the first value, as you see, and then I say seek to 8,000. So now the next position to read from is 8,000, but because I didn't read from it, it did not fail. Now if I come back up over here, now if I read, that's the time that it's gonna fail and come out. If you look at the thing over here, you see nothing's gonna be shown. No output is shown. Are we okay with this? Just a second. All right. Next thing we need to do is oh, well, the screen is gone. Okay, yeah. Same thing as EOF. EOF and fail, like you cannot check to see if you're at the end of the file or not. Again, end of the file only is when you are actually at the end of the file, not with seeking. Just be aware. That's that. So keep that in mind. Okay, now what I'm going to do is work with the employee. So I have a function, a class called employee, and the employee of mine over here is a class that does not have any resources outside of its scope. Therefore, when you're actually working with this, the um, you don't need to have rule of five for this one because the uh, all the data for the employee is inside the employee. Are we clear on this? Okay, so so I am going to write a code that does the exact same thing that we have done uh, with doubles, but this time with employees. So if just I just want to show you the compound file. So I had a vector of numbers over there. Now I have a vector of employees. I'm going to create a file called employee.txt and write them one by one inside the file. And when I run the program, it will see that exactly like the other one, because the insertion operator is overloaded for OStream, it's going to get called, and therefore employee.txt will get generated with all the records printed in it in text. So when you actually look at this, you have all the values written in here. And as you see, they all have different length. Again, the exact same problem happens. If you want to have the 13th record over here, you have to keep reading and passing delimiters. So you have to count the delimiters, 1, 2, 3, 4, 5, 6, until you get to the number that you want. You continue reading to the next delimiter, and therefore you're going to have the value. The problem is that it is impossible for you to know where the 13 value is, because each size is different, and it's absolutely impossible to find it unless you do a linear search and find the value inside the the, the file. Are we okay with this? Okay, so quick look of the thing just to make sure we understand what employee is. I have a simple what should we call it? A simple constructor that sets the name and everything. I have a less than operator for sorting and stuff in there. I don't know why do I have it, but whatever. I have a print that prints the employee. I have a read that reads the employee from the text, and I have print and read called in insertion and extraction operator for this thing to work like regular values. So this one is employee text out. Okay, now I can do the exact same thing in here. Instead of actually writing this thing as text, what I can do, I can change this thing to binary. Oh, not here. I can change this thing to binary, and obviously iOS binary. Okay, and instead of using insertion operator over here, I can actually say write reinterpret cast to, because I'm writing, it's going to be a constant character pointer, so const character pointer, and I am casting the V. Okay, this help thingy is killing me over there. The EMP actually. So that's the address of EMP. My apologies. Address of EMP, and I'm going to write it to the size of employee. Okay, or you can put size of EMP, same thing, just to make sure that it is exactly what you're the size of the size of what you're exactly getting, especially if you have levels of inheritance and stuff and you're using auto and you don't know what is the type. It's better to put the name than the type. Maybe the type is not what you expected. So anyways, it's gonna go to the address of the employee and to the size of the employee. It's gonna, without any interpretation, gonna write everything in a file called employee.bin. And when I run the program, obviously it's gonna create the file for me. Now let's take a look at that file and see how does it look like. And this is the file. As you see, when you look closely, you can actually see the name of the employees in there somewhere in the record. But obviously, the data is not what we expected. It is breed kind of, when you look at it, you can kind of guess what is where, but it's all over the place. It has lots of aligning and things like that happening. So you better not try. Just remember that everything is saved inside employee bin to the size of the employee, and all the records are set in perfect order. Now, if I want to read the information from uh, the text file, from the binary file in random, so we have the binary and we have the text file. So let's put this one binary. So EFGH binary, right? Now, if I want to be able to read the records from the employee file, that is text in random, which essentially means I want to jump to certain record and read it, I can do it. But doing so requires multiple number of loops happening for every single search that you have. Take a look. The show record of mine receives a row number and an IF stream where it's going to read the information for the employee from, a reference for it. It has an employee, it clears the file, it seeks to the beginning of the file, then it starts from the file and keeps going to the number of rows and reads them one by one. So the read that it does, it's reading the stuff from the employee one by one until it's done. And when it reaches to the last one is actually the one that it read, and it returns success if it's actually read properly. So the F over here is casted to a boolean, so it returns success. So if it reaches to the end, it fails. If not, it won't. So doing so is like this. So when I actually run the program, if I want to show the 10th record, when I run the program, if I want to show the 10th record, what happens is that, oh, first of all, showing them one by one. Showing them one by one is just reading them from the file because we have overloaded. This one is going to read it from the file, from ifstream in comma separated value, and print them one by one, which is perfectly okay. So as you see, everything is written. Now we'll run it right down to this place around the cursor. Everything's printed. Those are the ones that I have. Now if I want to show the 10th one, what I need to do is to go to this place, clear the file, come back to 0, and start reading 10 records. So essentially it keeps reading records over and over for 10 times, and the last one is going to be the 10th one if F doesn't fail. So now it's going to show actually number 10 is Chip Davis, whatever. Okay? And then it comes out and shows success. And for the 5th one, the same. For the 15th one, the same. But if it's going for the 100th one, it's going to read the entire file. That is 19 records. After reading all the 19 records, it hits the end of the file. Then F is going to go false in here. And when the F goes false, that's when the rule, the 4 is broken. And it comes out because it's failed. It says end of the file was reached. I couldn't find anything, and obviously it's going to return a false, and that's how it can recognize it. Do we understand down to this point how it works when you are doing sequential read? All right, now that we know this, let's see what is the mistake that people can make. So this is a sequential read. In here, I'm going to say HI, sequ sequential. Uh, it's kind of random access simulated in sequence. So I am simulating random access, but it's essentially not random access. Now take a look at this. The program could have been written in this way. If I wanted to show everything in here, instead of going it by that, I could simply say for I less than 4 file, or while file, and in here I could simply say show record, or while, even like this, show record plus I, and pass the file to it. So when I run this program 3 years later, you will see that everything is shown. It says end of file reached. Anybody understood the logic of writing the code that has been written? Now my question is this: how many times you think a record was read in here? How many times I read a record in here to show all the 19 of these? How many records were written? How many reads was done? Let's put it like this. In line 26. Oh, okay. Okay. I didn't see the answers. Now I'm looking at the answers. Give me a second. So let me see. Oh, there we go. 361. So nice try. Like uh, It is almost okay. So the formula for it is actually this. The number of things that are written is this. So it's n. Uh, it's n n multiplied by n multiplied by mm, n plus 1 divided by 2. So that's the number of reads that are an n being number of records. Okay, so it is 19 multiplied by 19 plus 1 divided by 2. Now, if that's 391, you were absolutely right. Okay, so um, uh, 361. Let's see if actually that's the number. Let me check it out. So it's open parentheses 19 multiplied by 18 divided by 2. That's 171. So 171. So yeah, so this is the number of times that it's read. And why is that? Because every single time show record is coming, when one is read, it reads one, that's one read. To print the second one, it reads one and two, that's three reads. When it wants to print the third one, it reads one, two, and three, that's six reads. When it wants to get the fourth one, that's 10 reads. Then it wants the next one, then it becomes at 15 reads. And it keeps going like that. Do we understand this? And that's extremely, extremely inefficient. Okay? So random uh, sequential read is inefficient. Sequential read is inefficient. Okay, keep that in mind. Now let's see how we can actually do a random binary read. Now if I want to do a random binary read, look at the difference between the code and how simple it will make it. Take a look. I have the exact same construct in here. The difference is that when I say, now I want everybody to pay attention to this. This is extremely important. So I have the row, I have an employee, I clear like the other one, but instead of seeking to the beginning of the file, I'm going to say seek. Oh, uh, sorry, I thought something went wrong. My apologies. Hold on, receiver, for a second. It's my doctor. I have to answer this call. My apologies.
Sorry, we can't hear you.
Can you hear me now? Can you hear me now?
Yes.
Okay, sorry. For some reason the microphone was disconnected. All right, one more time. So I'm saying now take a look at the random type that random access read that I'm doing. So it looks exactly like the previous show record that I had, but the difference is that Again, like that one, I'm receiving the row, I'm receiving the file, that I am receiving, that I'm clearing the file, but instead of seeking to the beginning of the file, I'm seeking to the size of the record of the employee minus multiplied by row minus 1. So essentially what happens is that it goes right before the record that I want, right at the beginning of the record that I want. And I say at that moment, read into the address of E to the size of the employee, therefore that one record will be read, and then I'll show it. If the read is failing, it's fail, otherwise it won't. So everything works the same way. The difference is that when in here I use the show record to actually show the record that is getting printed. Sorry, that is getting printed. It's so yeah. So in here I can actually say doing the exact same thing. I'm going to say show record, and in here I'm going to say plus plus I, and from file F. Oh, so sorry, from file, and that's it. Because each row that is being shown jumps exactly to the place, it doesn't make any difference. It's reading straight, it's reading sequentially down. It's exactly the same amount of time that it's going to take, and the outcome will be identical to the other one, but in a much more efficient way. So when I'm actually reading 19 records, I am reading 19 records, not more, not less. Um, oh, and it stopped over here for some reason. I don't know why. Let's continue the rest. And there we go. Are we okay with this? Now, this is all fine and dandy and everything looks beautiful until we do this. I'm going to remove the employee. Remove these. And instead, I am going to add existing items that are the exact same employee that I had before, but the difference is that this time my employee has resources. Therefore, it needs to have, if needed, it needs to have assignment and copy construction, copy assignment, and all those things to be set. So what I'm doing, because I'm not doing any copying in here, I am going to just overload the assignment operator, and that's it. Um, uh, and we have the assignment, move assignment, the move constructor, and copy constructor. These are all set up, so there's no problem with moving these things around. The only difference between this and the other one is that this one is has resources outside of its scope, and the other one does not. Every other thing is identical. Do we understand this? Okay, now I'm going to bring back the binary right, and then we'll see what happens. So let's take a look. I'm going to go back to my the file that I was doing binary right, employee binary right. So I'm going to take it like this, copy, come back over here. So I'm going to do a binary right. It does the exact same thing. The difference is that in here I'm going to put D underline employee bin. So same thing. So what happens over here, it's reading everything and writing them down. Okay, so let's do it and see what happens. I'm going to just start writing everything. So again, please um, see what's happening here. When you are writing the employee, it gets the address of the employee with the size of the employee and writes them all in the file with the size that they have. Now, when I run this, it wrote everything. Let me bring it in. Take a look. Do you see any names in here? It doesn't seem that anything like that is happening here. So something is fishy. It just doesn't make sense. So what's happening here? What's happening is here is that exactly for the same reason that we have to apply rule of 5 when we have classes with resources, writing in a file will have the exact same problem, which means when it actually writes in a file, oh, let me see if actually I have a read and write for here that is not used, which was very fine. Okay, writing in a file, if I just writing it in a file, it's going to write the file, which are these values. The problem is that this doesn't contain the data. So when you have the file, let me show it to you. So when you have your array, this is your array of employees, and your array of employees, they have the names all over the place. The names that they are holding, they are not inside the array. The names are all outside. So what is being saved in the file is essentially this. And the data that these things are pointing to remains in memory. It's not going to go in the file. So if later I want to read these values and bring them back in like I did before, I will read the addresses that was pointing to data when the previous program was running, which means they are not accessible anymore. Your computer is in a new state after the execution of the last one. It's all garbage with that. Therefore, for this, we need to be able to do the exact same thing that we have done in copy constructor and copy assignment, which means deep saving. In here, we did decopying, but in here we have to do deep saving. Because of that, I added two more functions, write and read, for the employee, which essentially their job is to not only write the data, but also not only to write the attributes, but also write the resources outside of the data. So when you look at the write in here, take a look at my write method. Oh, sorry. When you look at my write method in here, look what the write method does. For write method says I need two files for this, not one file. One for the class and one for the names. So what happens, it seeks to the beginning of the name file, seeks to the end of the name file, whatever the name file is. If it's empty, it's going to be beginning. If it's not, it goes to the name. Then it asks what is the location of the name file, whatever it is. Let me explain how it's being saved. I'm going to draw it first, and after I draw it, then you'll see what's going on. So these are the employees we have in the array. I have 4 employees in the array, and each employee, they have a data of their own, which are this one, this one, this one, and this one. Let's say the size of the data over here is 10. The size of this one is 20. This one is 5. And this one is 8. So essentially what I have in here will be as follows. Again, this is employee 0, employee 1, employee 2, employee 3, and then employee 1 has a name with size 10, employee 2 has a name with size 5, the other one size 20, and size 8. Are we okay with this hypothesis or this assumption? Okay, so now if I want to save this in a file, how can I do that? First of all, I'm going to need 2 files. It cannot be 1 file. One file should be there to keep the employees. The other file should be there to keep the names of the employees. So what do I do? This is what I'm going to do. Take a look. I am going to create 2 files. So this is the file that I have for employees. So essentially, and this is the file that I have for the names of the employees. So essentially, I am going to save double salary number, whatever that is inside the employee, all these attributes in here. And whatever the name of the employee is, all the names that you see over here, Homer, Nat, yada, 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 they're going to be saved in the green one. Are we okay down to this point? All right. Now, let me bring up the right so I can actually do it exactly as right does over here so you see what's going on. Okay? So let's say the program just started and I want to save these 4 employees in a file, and I want to write the very first one in here. So what I'm going to do over here, first it's going to seek to the beginning. So this is, let me just put the names over here so we know which one is what. This is NFS. This is OFS. So this is where all the names gonna go. This is where the object is gonna get saved. Now let's begin. So first it says seek to the beginning of the file. So when it seeks to the beginning of the file, it stands at the beginning of the file right over here because they're both empty, it just started, right? So it says, tell me what is the name location. So name location, let's put name location will be, will have the value of 0 because it is at the beginning. So the name location will be 0. So in here, so remember that name location is 0. That's the first value that it's going to get. Now it's going to get the name of the first one. And we said, let's say the name of the first one is 10 characters. 9, it's going to get 10 over there. So it's 9 in length or whatever you want to set it. Let me see. No, we don't need to. So whatever. So whatever the length is, it's going to put it over there, which is in this case is 10. Okay? Then it's going to write the name of the write the length of the name inside the NFS file. So essentially, right at the beginning of this, it's going to write, so right over here, it's going to write an integer, and that integer will have the value name len was 10, will have the value 10. So 10 goes right in there, and that's just an integer. Then after that happens, that's written, okay, it's gonna write everything that it it has over all the information that it wants to write for the current object. It's going to write them all in the OFS. So employee number one will be saved into the OFS. So this is going to come right down to here. So that's the first one that's going to be written in here. Then it says write the name location in OFS. So it writes another one, and this one will be the name location that was 0. So therefore, in here is going to be, why it went back to 48, I don't know. It's going to be 0. Then it writes another one that is length of the name. Okay, so, oh, sorry, why did I write over here? I wrote something wrong. My apologies. Let me fix this. It does not write the name over here. It writes something else. So let me fix this first. So let me remove this one. All right. One more time. In here, when it writes it, it's writing the name with the name length. So essentially, it's writing that 10 character name thingy over there. So that's going to be written in here. Like this. And the length of it will be 10. Okay, that's the correct one. My apologies. And this one is 10. Okay, so this is the first record that is read, that written. So the name is written over here. Then the object is written over here. Let's make that object red so we understand that it's actually the object. So the object, I do red and it writes blue for me. I don't know why. So the object is written over here, and then the 0, that was the location. So it was the name location was written over there, that was 0, and then the length of the name, that was 10. Now this is the first one that is written. When the second one is written, it works the exact same way. So what it does, and it's ended, it comes out. If they both successful, it comes out. For the next one, again it starts, and now we are on the second one. So this is what we are writing now. We are on the second one. This is what we are writing now. Let's do that, and that's the end of it. So it's going to first go to the beginning. So it's going to go to the beginning of the file. It's going to go to the end of the file, which is here. So it says seek 0 and n, so it's going to go right over here, stands over here, and it says put name lock in here. So what's going to put over here is 10, because 10 characters were written, so the name location will be 10. Then it gets the length of the name, which is 5, so 5 will go into the name length. Then it writes into the file to the name length the name of the object. So the name of the object will be written over there, and the name of the object will be this. The name of the object will be this. And the length of it obviously is 5. Then it writes the entire object over here, so now the object will be written over there. The second object. And after the second object come the two. After the second object come the two name block and name len. Now the name location of that one is 10. And the length of it is 5. So, and it keeps going like that for all of them, which essentially means you will have the values copied one by one, the location of each name, and the length is going to be there. So let's say now the read is supposed to happen. Let's say the read is supposed to happen, and we want to read the second record in the file. So we want to read this one in the file. I'm going to remove all these. So all these things are removed. We don't have these anymore. We only have the file, and we have one employee someplace. So this is the employee that we have. One employee over here. And this one employee of ours has one pointer over here that is supposed to be the name. And we want to read the second record. So what happens is this. The file location currently is here. And the second employee wants to be read. So the very first thing that it's going to do, it's going to because it's reading the current object, it's going to delete the name of the current object. So this read looks like an assignment operator. Okay, so first it deletes the name of the current object. Then it says read into here size of the current object that is employee. So all the value inside here will get copied into the employee. And because at the moment it was pointing to some garbage over to its own value, it will try to point to the same location. But in this location, all it is garbage. No worries. This is the first stage, just line number 74. Now, it goes and reads one more it does two more reads. The very first one is name location that is a size T. So it says read name location. The name location that will be read is 10. So name lock over here will be 10. Will be 10. Now that the name lock is 10, it reads the next one that is 5. That is name len. That is 5. So these two values will be read. Now it says, were the reads successful? Yes, it was. It says allocate new array of characters with the name that is 5 plus 1, so it can hold it. That becomes name. Then it says in the NFS file that is here, seek to name lock. Name lock is 10. Because name lock is 10, it is going to seek to position 10. Then it says read into the name name len. So all the values in here, oh, the allocation, I didn't put the allocation. So the allocation was done. So this is actually allocating something now for a length of 5. That's number 78. Now it's seek to that one. Now it says read from into the name. It's already a character, name length. So all the information, all the name that was saved in the file will be copied in the name. And it puts a 0 at the end and makes it null terminated. Therefore, the value of the class is correctly read and restored from the file. The part that is equal in sign is kept into the object file to be saved, and names that are variable are held into the variable part of the variable file name, which is name file. Then, because each allocation, each writing and location is saved in the object file, then it can easily be retrieved later on. In databases, you call these things indexes. So essentially, when you create an index, this is how it happens. It puts all the records with the same size in one table, then creates a variable length table, but in the other table, it actually holds all the data relative to it. Therefore, all the information can be read like that. Now, the code over here is fully implemented and it works exactly as I mentioned here right now. So now, if I actually go back over here and get the employees, I'm trying to find out where I had the code for it. I don't, let me see. Okay, I don't have the code over here. Let me go bring it from where I put it. Here we are. So to write all these values in the file, this is what I'm gonna do. There we go. Now we're in business. There we go. So instead of writing like this and putting garbage, and again, please look at this file that it's all garbage. What we're gonna have over here will be this. Instead of writing like that, I'm gonna write it like this. So what happens is that I have all the employees. I create two files. One, I call it the employee bin. That is the dynamic one. And the other was the name bin, both binary. But when I'm writing, I'm passing the two files to the right. And when I run the program, it's got to go through the write everything in a file. First, this file have been, yes, reload it. Yes, reload everything. Okay, so now when we are here, take a look. When I'm actually opening this, still I can't read anything. They're all binary values that I had, but I have one more thing in here to look at. That's the name bin. And if you open that one, you will see it's all the names of the classes back to back with no delimiter. Why it doesn't have delimiter? Because the location and length of each name is kept in this binary file. And I can, so this one, let me just put it back over here. And I urge you to please go with F10 and F11 on Visual Studio, walk through this and see how it's being written. Draw it as I did with one of these pens with color to go through it and see exactly how it is being saved. So that's that one. So this is JK, that's binary save for classes with resource. And to read it, the process is exactly the same but reverse. So I'm going to exactly read the way I wrote in it. And here is the one. There we go. I'm opening the two files for reading. As you see, IF stream, I am passing the files values to the files. Let me just walk through for the first couple so you can see how it works. It starts here and passes the file. Now it goes in here, gets the name lock and everything. Now if you read this, it reads the file. So now if you look at the, I'm going to go over here and I put this. This in here. So as you see, salary is there, employee number is there, but for name, error reading. You see that? So it cannot read anything for that one. But now what it's going to do, it's going to get the name location and the name length. Name location obviously is 0 because it's the very first one. Name length would be 13. That was the name length of the name. Now it comes over here, allocates 14 character, seeks to the offset 0, it's the beginning, reads 13 characters in name and null terminates it. And now you will see Homer Simpson is red. Then it goes out and goes to the second one. Oh, and prints it out, obviously. Now it goes to read, one more read, reads everything, obviously error reading. Now the name location over here is 13 and length of the name is 12, so the next one is allocated in red, and so on and so forth, and everything is printed one by one exactly how it's been saved in the two files. Are we okay with this? And if you say you're okay, you're lying, but it's okay. So how are we overall with this? We okay? All right. I really encourage you to please go and review this and go through it to see how it's done. Okay, it's um, an interesting thing to walk through. And that concludes the file thingy that we had. So you go through this, you walk through this, and you understand how it works. You know everything about binary file reading and writing because everything's there, and you can see it has addressing and seeking and jumping and indexing, and all the things that you want are in this example. So everything is fine and dandy. We have till 3:15. I don't know about you, my back hurts, my mouth, my vocal cords hurt. Let's have 5 minutes break. We come back quickly. We're going to go through file system and understand how it works, and we'll call it a day. So break for 55. Yeah, 20 minutes is enough. So break for 10 minutes. I'll see you in 10. All right, 4 people are saying yes. 5, 6, 7. Total of 14 people in class. Actually, not 14, 12 people, but let's go. 8, there are 9. 4 more to go. 3 more to go. to go. All right, good enough. Let's continue. Um, so for this part, we got to make sure that we have definitely C++ 17 active over here, because this is in C++, purely in C++17. So um, the std file system library was introduced in C++17, and it provides a platform independent way to work with the file system. It You can do operations like path manipulation. You can go through uh, browse through directories, and you can file creation, metadata retrieval to see which date the thing was created and things like that. So it goes through all the good stuff. So how does it work? This is how it works. So essentially, we are in, let me show you. I'm going to say using namespace, using. And I'm going to create a namespace out of file system so I don't have to keep going through file system, file system. So I'm going to say namespace fs file system. So fs scope resolution is essentially the file system. Now, return 0. You can, there's something called define as a path. So you can define something as path and set it to a path. And the path you are creating essentially works like this. As you see over here, I have example.txt, and example.txt is shown over here. So that path is essentially holding a path for whatever you have. Now, the good thing about this path is that you can actually set the path. So let's say I have a couple of paths over here. Path 1 is home username user documents, and I have file.txt. What you can do, you can join the two paths with the overloaded slash operator. So you can say full path is p/p1/p2, and it combines the two paths, and therefore your full path is going to look like this, as you see. Okay, so it is platform independent. Depending on where you are running, it's going to set it that way. Because we are doing backslash over here, it does it that way. But don't worry about it. If you see stuff like this over here, they would work perfectly on your computer anyway. If you have Linux or Windows based or any type of operating system, it will work in it. No worries at all. So let me just save over here. LM, and I'm gonna start this with FS so we know it's file system. So file system path. The next thing we need to know about path, things that we can do with path, is that with path you can actually extract information out of a path. So if I have path set to something like that, I can simply say file name, and I can say p.filename. That returns the file name for me. Extension gives me the extension. Parent path, it shows where it's actually in, and very useful to find all the information that you want. So you see, I changed the wrong name, wrong file. Sorry, save. Yeah, so if you run it, you'll see that you can extract file name out of it, extension out of it, parent, everything. So this is very, 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 very useful. You can see exactly where the file is, and you don't have to go traverse. You can do all these things using string yourself, but no, this is easier. Info in path.cpp. Okay, so you can check to see if a file actually the file actually exists in the where you are right now. So I'm gonna do it like this, and then I'm gonna do it like this. So I'm gonna say now P is set to say copy, and run it. Oh shoot, I keep changing the wrong one. My apologies. I don't know why I'm doing this. Sorry about that. There we go. As you see, the first one, example.txt, doesn't exist, but the employee.cpp does exist. So that's, oh, and also you want to check to see if what you have is a file or it's a directory. You can actually use this. So you can actually say if it's a regular file or if it's a directory. So it tells you if what you have in there is a directory or not. So um, open file folder. So this is a directory that I have over there. I'm going to copy that. And in here, I'm going to say P is around that. There we go. So you know exactly which one is file and which one is directory. So it gives you all the access to that. So, uh, so this should be N O. File and directory check. To create and remove directories, you can use create directory. So I can simply say over here create a directory, and if you can create series of directories back to back, parent child, so it creates three directories back to back and goes in one call. You can remove uh, file or directory. For this one, I'm going to put it in comment. I don't want to delete everything over here. So you can remove example.txt, deletes that one. And if you say remove all parent, it recursively deletes all the directory and its contents. Careful with these uh, functions. And for the rest of it, let me just bring it over here. Oh, and this is actually good. So this, oh, it's creating parent, and then it's deleting it. I'm gonna comment these. So create and remove. directories. Next thing, uh, let's go through all the directories in a file. So I'm going to create the directory as current. Then I'm going to say create a directory iterator. So it essentially creates a container of directories, and each entry path will actually be displayed. So using this, you can actually see all the information that you have in the file as you see. So these are all the things that I have in the current directory as we are going through them. And if you want to show everything inside the directory and go through it recursively, you can do that too. So if I run the second one over here, it recursively goes through all the subdirectories too. And as you see, everything's there. So if you want to search for a file within the whole directory recursively, that's what you need to do. Copying and copying and copying and copy operation for files happen like this. So you have the file, you have the destination, and you have options. You can actually see if you want to overwrite. So all the options that you have, you can go like this, so you can exactly see what type of different things that you can have. So yeah, you can rename the files. So copy is copy, that's fine, but this one is rename and move. So if you want to move one file to another directory, you can rename it and put the full path with the directory for the second one. Then it's going to move everything from everywhere. So that's copying and moving. Again, these are not in the. I don't think there is in this in the subject outline, but yeah. So we can have something like this. So in here, I'm going to put the name of the file. So let's say put the employee bin, copy it. Now I'm going to say if it exists and if it's a regular file, now tell me what is the size for it. So it's going to actually get the file size. So you'll see that the size is 1064 bytes. And this gives you the size that it actually, I think it gives you the size that it occupies on the hard drive. I'm not 100% sure, but it gives you essentially the size of the sector. But so if it's more, I'm not 100% sure on that. Check that one. You know what? Add a few bytes to it so it becomes more than that. See if it suddenly jumps to the next step. But yeah, so that's the size of the file. And you can always check to see when was the last write time. I think we need C time over here. C time and oh no, and chrono. Was it chrono? right? Yeah. Where is C time? Is C time 2 time T? Type T? C type? C type? Really? Let me see where it is. Let me check where it is. Yeah, it's part of Chrono. Chrono. So why is it giving me an error? Not a member. System clock? No. Hmm. Files is a file system. I'm not in file system. Why is this file system? Declare type, clock. Just a second, let me see what am I doing in here. Am I making a mistake? Time to. It is chrono. Is a member function of std chrono system clock class. So this will be std chrono, seriously, std chrono system clock std chrono system clock. Now it doesn't accept the F time. Anyways, okay, the code I have written, I should have tested it. I didn't test it. It's my bad. I'll find out what it is and I'm going to do it later on. CF time. Let me see. Let me test it over here. It's already 3:15. This should work. Chrono C time. IO stream file system chrono C time. Anyways, I'll debug it and I'll show it to you later. I don't know why it didn't work. So I put the one over here. This was what was it? It was file size. File size. Okay. I know it's 3:15. If you have to go, go. I'm just gonna finish the things that I have. Then I'm gonna make sure that it's done and set properly. So after that, it's permissions to see what are the permissions of the file. So permissions are set like this. So essentially, so permissions are like that. So you can set the status. You put a path over here and the permissions. Then you can go through the permissions and see if it's writable or not, depending on what the permission is. So you can actually look at the permission over here and see all the permissions that can have for a file. They're all there. And these are all platform independent. So um, based on the platform that you are, you can actually decide what the permission is going to be. You can check for your permissions. Q permissions, and that's it. So I will post this thing that I created for all of them. So and exactly which one is doing what. Um, I hope it's going to be useful for you. It's an important thing to know when you're dealing with files. It makes your life much easier. Anyways, that's it. So any questions before we go? Any questions? Yes, Farida.
Actually, it's not related to the class. I just had another
Okay, so
question.
let's after the class call me.
Okay.
Okay, thank you. All right, everyone, have yourself a beautiful day. I'm just going to stop the recording and post the notes. Have a good day.